All right, my dudes. Hopefully you guys can see me. About a minute late. I was trying to organize my thoughts on this outline, and I went ahead and posted the outline in the description. So you guys should be able to refresh and see the outline that we're going to cover today. Try to give you guys some level of organizational structure to what I'm going to cover today. And it goes into where I've been, what I've been doing. Hopefully you guys can hear me loud and clear today. And if you are new to the crypto space, if you're a veteran in the crypto space, this should do very well for both of that. So I'm going to just kind of cover what our experiences have been over the last few months since we really started, haven't had a lot of videos with you guys. I miss you guys. It's good to see some folks, joining, and hopefully other folks will be able to see this later. It's been a minute since we've had this, but what I want to cover is really the design, the development, and the deployment phases of now that we've moved into the Bitcoin space in a kind of a larger standpoint when it comes to infrastructure. Glad to see that you guys are here and you guys can hear me, and kind of walk you guys through some just lessons learned. Like I've always said on this, in this space, is observe and report is critical. Being able to share your experience is critical. That's how this community is still one of the best communities out there in the space, because we share a lot of information, and you got to treat it like a recipe and ingredient, but not a lot of people know how to cook. Right. So what we're going to do today is a recipe and ingredients to kind of get an operation up and running. And there's a lot of lessons learned, and we're going to cover some of that stuff. So I'm going to get right into it. Again, in the description, I had placed kind of an annotated outline. I had ChatGPT help me organize it because I had just a whole bunch of notes and put it in there and said, hey, kind of structure this based on, the kind of design, develop, and deployment. So, when you're looking at any site, or let's say you're helping maybe a potential investor or somebody that is wanting to get into the crypto mining space, immediately most people that would call us would be like, hey, I think I got this great location. Supposedly it has good power, and let's go build something. And there's way, way, way more to it than that. We'll get into some of this here of what it is, but identifying a key location is pretty important. And what I would say is with any of that, especially if you're going to be supporting that from like you're the person that's going to be maintaining it, or you're going to be taking that effort on once it's deployed, continuously improving it, and that having it close to where you live is a pretty critical thing if that is possible. And there might be options that you don't even know possible, much in like what we had here. We had the BBT farm up in Wisconsin. I'm down in Illinois. That was what we had back in 2016 through, still even current. However, there are opportunities potentially in your local areas that you don't even know. And that's kind of what we did around here, is work with a local power company to establish a rate for everybody that made sense based on their available power that they had that they could use, in this new rate plan. And you really got to work with your local, power folks. I like going straight to the power company, the producer. There are a lot of, I would call them middle people in the mix, that work various different hedging rates. Potentially they're selling power across the grid and transmission. I kind of like to skip past all those folks and go straight to a power producer, because you might be able to find an opportunity maybe on the site itself and not have to go through transmission. And that's one of the things I'll go out there and say is, if you're doing some exploratory work, you really want to try to establish and make sure you're upfront with them that, hey, here's the stage in where we're at with regards to maybe putting a site in place. If you don't have capital or you're not really there yet, you're just looking at what's the opportunity value here. you could be very transparent with them and say, hey, we're not necessarily capitalized just yet, but if we're able to present a plan to go get capital, we need to know this information. So it's like a chicken egg kind of thing. Like, what needs to come first? You got to see if it's even feasible, right? So reaching out to like a business development person at a local power company is a great way to start with that. And you can identify, is there power options? What are the energy costs? There's really about four, like from our area, there's like 4 different pricing components to what makes up the power bill. And it really comes down to if you're on primary power or you're on secondary power, which just means you're getting it through some other level of transmission. And think of it like a rent seeking kind of thing. Like if there's a power production in one spot and then you come down the line a little bit, you're pretty much in that first phase, meaning like they do have to transmit to you. You got to put a meter there and you're in front of the meter, right? So there's a meter there that's going to measure that. And then if you're on a power production site, you're what they call behind the meter. So you're essentially just catching it off of what they can ramp up maybe a power plant up to, and you're able to catch it before it starts to go through transmission and stuff. And that's probably the leanest cost that you'll find. However, it's really, really difficult to get onto a power plant. You want to be like that first primary power if you can, because then you save the extra transmission cost. And, we can get into that in a lot more detail, probably in another video to explain like NCP and CP costs, which is your non-coincidental peaks and your coincidental peaks. Those usually have different power rates and costs. So you might have your energy rate, you'll have a CP cost and an NCP cost. And then you'll have like your taxes, and any other kind of maybe transmission, distribution charge. And that's usually a little smaller, but, to give you an idea, that's kind of the breakdown, and understanding those and just kind of having those to where you can put into like a pro forma and you can kind of figure out like, what's my actual power rate going to cost? You'll see that. Now above that is all those different rate plans that you usually see. Like if you are just doing research on your power, and you see, hey, I have a residential rate, it's 12 cents, it's broken down in this way. During non-peaks times, like in the evenings, I'm only paying 4 cents, and in the peak times, I'm paying 12 cents. And you can adjust your usage internally and locally, and this is what I've always suggested to folks that are doing like smaller GPU farms, is pay attention. It is worth your time to look at your power bill and then go to the power company and see if there is what they call just time of use. And if you can find a good time to shut down certain times, like maybe you're not running 24/7, maybe it just makes sense to run 18 hours a day or 19 hours a day. And you can literally save like a majority of the bill, like 60% sometimes. Most of the time it's like 40% you can save, but around 60% of your costs. Because sometimes your peak rates during like the summertime might be 16, 18 cents per, for that time. And then it drops back down to 6 cents. So understanding your peak rates, like if you're at home residential, you're still using your 200 amp at your house, that kind of thing, time of use really works well. In larger Bitcoin standpoint, it all comes back into finding out what your, your total potential 3-phase high power options are. Most of those are considered under commercial or industrial rates. And those usually typically are anywhere from 7 to 9 cents across the country. But these other rates that I'm talking about working with your power company is there might be a way for you to get in to where you are what I would call an energy consumer that helps flatten the curve on the dips, like in the evenings when they're not using that much power. There's still excess power out there that they can sell. So then they'll look for an opportunity to maybe give you a better rate. And then maybe during the days, they'll ask you to curtail so many times a month, right? So you'll have these options to where you can kind of pause your mining and then have a cost avoidance element to the thing. But understanding those power structures are very critical. So it's not just about location and that you can get power. It's also what your costs are. It's your most important thing. It's what allows you to figure out, are you going to be able to operate or not? That's your most critical piece. You want to be one of the last to turn off if you have a down cycle in Bitcoin as an example, like if you're mining Bitcoin, or even with like the transition from Ethereum moving to proof of stake, and then folks looking at what's there to be able to mine and participate in these networks. Because, from a general hobby standpoint, like we've always loved mining. We've been part of mining since essentially the beginning, or damn near the beginning, right? And we've been on this channel helping you guys kind of get there since 2013. And it's a hobby. It was very hobby first, and now it's kind of turned into more of a business standpoint for us to try to expand and get, larger in this space and be able to provide more information and be able to expand our own team. So as we've learned more with this, trying to find out how to operate and not just get turned off because, Ethereum shuts off or, some other existential situation happens that I can't, pivot and move. So understanding, what your power cost and infrastructure is critical. Then you got to look at, it's more than just your location and just the fact that you have cheap power. You really need to look at like the existing infrastructure requirements. And I'll take it no further than what we did here, which we looked to see if we could get on a substation. Like, could I lean out the cost to like put a box as close as I could to the power purely for the cost savings of trying to extend service to it, right? So in our particular containers, we have 4 containers, 5 megawatts worth. To try to like hook that up, the containers we have required CU only, which is copper. So copper line at 500 MCM, which is about that thick. It's pretty thick. Parallels per service entry, that's roughly like almost $90,000 just in copper, just to extend service, right? So you start adding these numbers up. We're having to get a general contractor to go in there and lay everything down, buy the spools of copper to be able to hook up the services to the 800 amp panels. And there's 3 800 amp panels per container. So that's 12 service hookups with 3, it's 3 line on 3 phase, right? So you have 3 parallel 500 MCM copper lines coming through that. And then it's a math problem on the distance and timing, right? So if you're trying to lean out those costs, trying to figure out how close can I get to a transformer and extend that service to ends up, it's real dollars and cents. Like if we would have done this offsite, just down the road from the substation, we would have had the transformers brought closer, service would have came to the transformers, having the distance of those transformers to our containers still irrelevant there, right? Because that extension cost could be, $1 million to extend power down range. So finding that kind of situation. So really understanding all of your different cost structures of how much your build is going to cost is very critical too, because that's going to feed into what your IRR is, your initial rate of return, your ROI, like why we all love to do crypto mining. If you're doing it in any kind of scale, like it's got to make financial sense on at least some level of payback for the infrastructure cost, right? And the money that you're putting into it. And then, you are a participant and you're providing it there, but it's got to have some level of return. Otherwise you're just burning through money and you're going to have this infrastructure, most of which you can't take back out, right? I mean, it's like wires in the ground, hooked to a service transformer. So you got to really understand that and try to figure out how can you lean out those costs. So if you can get onto some kind of substation or be right next to the fence, you can greatly save your cost. We total going from down the street to moving on the substation potentially saved like 80% of our cost moving it right on top of the substation. Luckily, we found a power company that would allow us to do that, but it's just, that's part of it. So, understanding all your different infrastructure costs, you got transformers, you got switch gear, which essentially you're going from 3-phase high voltage and you're transferring it down to like a step down transformer. You would have switch gear in between that. And that's for the fault tolerance. If something happens like internally in the container or something and it sends it back, it wants to have a fault break between that. Switch gear and the fuses and all that. And you guys have seen that if you watch any of the 2500 GPU video that we had a while back when we walk you guys through the GPU farm. That there was a 3 megawatt service that we were only using about 1.5 megawatts of, but we have the switch gear in there. We show you guys kind of what that looks like and how the service comes in. That there was 415, 240 service, step down to 208. So we had 208 service in there. And we had switchgear that was for that. Our current site has 480, 277. So, you know, and it's directly connected. It's not, we have, you know, just a service shutdown and, you know, no switchgear. We're going right from there with no switchgear. And because we're on the substation, it's like essentially a cabinet that's giving us single phase 277 for the miners, which required us to have, you know, specific power supplies that could handle 277. But if we were going to do our first original plan where we were taking 480 to 415, 240, we would have had step down transformers. I actually have 12 of them in the back that we just finally have sold because we had purchased them. So it's one of those things, like we thought we were going one path. Our infrastructure was all set up that way. But then when we found out we could get a little closer, it was a math problem. It's like, okay, I already spent, you know, $120,000 in transformers. I don't need switchgear, which is another $120,000. I can get closer, save on wire, save on switchgear, save on step down. And then, yeah, now I just end up with extra transformers that we can end up selling. But that's the kind of decisions that happen, that even if you have a plan and you start to peel it back, that is, as the other parts of, you know, your build and your solutions start to come together, it may present other cost saving opportunities where you have to make a decision, and that's okay. I think that's part of that build. It would be nice to have all the plan laid out, and sometimes that does work. I haven't found a lot of larger operations that just build a plan, a very waterfall, and just go and execute it. You always have things in the middle. That's one thing I would say for anybody doing any kind of big projects, is understand there's always going to be change, and it's just how you adapt to that change. But like in that particular case we just went with straight 277. So project management is kind of my next thing that I'm going through right now with you guys, is understanding how to handle the construction, how to handle the zoning. There's permits, logistical considerations. So like where you're going to store your miners. You got to have, security set up. You're going to have, you potentially may have in a larger operation, like a 5 megawatt operation, you might have a few $1 million in cryptocurrency miners setting in your shop before you deploy, right? So you got to consider all of those things logistically, how you're going to get them there, all that kind of stuff. With the zoning and the permits, it could be easy in some jurisdictions, and it could be a really, really pain in other jurisdictions where they may want a sound ordinance test. They may want a before and after, and you got to plan for those. Those things can be anywhere from $3,000 to $5,000 to handle, just for like, here's what it sounded like before, here's what it sounded like after at various different distances, just to make sure you have the due diligence done to make, if anybody is complaining about sound or anything like that, you can say, well, here was the spectral analysis of that before, and here's the after, and here's some mitigation opportunities we can do with like tree frontage and that kind of thing. So have those kind of considerations, and just be realistic about it, right? You're going to put this thing somewhere and it may make more noise than the other, and you got to kind of consider that. So I think that is one of your biggest elements you need to look at, is like the management of that and how that project execution is going to go. From a capital, this is probably one of the most not understood things out there, is your capital expenditure planning. So especially if you're working with like a capital group or somebody that's financing it, just because like the whole project might cost $4 million doesn't mean you're going to get $4 million up front. And you shouldn't. I would push back against that. If any large capital providers are just trying to write you that check, hold up on that. One, you might not need all that capital. Two, you want to have a plan of just slow rolling that in, right? So you want, if you're building your costs, that should only, let's say your first phase of that, breaking those phases up, are going to be roughly $380,000. Well, that will be your first, infusion to start kicking off the program. And you can see your burn rate. You can see, are we hitting what we've planned to do, or are we exceeding it? Because you want checkpoints through any of these processes if your costs go way out of control. Because you got to figure out, like, okay, what did we not plan for here, and learn from that. And then it allows you to refactor moving forward. Like, do I have to allocate more capital here because now I've had so that continuous review of your spend is critical due diligence. You have to do that to understand on how you're spending and make adjustments through it. We were doing that where we staffed up pretty heavily, and we really kind of came to a realization that we don't necessarily need all this staff to do that, because it just, we had a very basic plan. We've deployed many things before, but like, given our circumstances of where things were at and stuff, it started to make sense where, as other folks had left, we didn't necessarily need to replenish them, because it was like, okay, here's our current burn rate, and it might make sense at the moment of deployment to bring folks on. So understanding your capital expenditure and planning cannot be undersold there. It's your schedule, your performance, measure yourself, make sure you're doing the things. We apply an agile methodology to everything that we do with this. So we do morning stand-ups. We kind of go through what's the plan, and then our execution strategy, that's to review it. Did it go like we planned to? I have a weekly Friday messages out to the different folks that we do business with, right? So we have our own operation plus the other operations that we support. We provide them like Friday updates. Like, here's what happened during the week. Here's kind of what's going on. Here's where we think you need to make some changes to. And then that helps us make sure that the capital deployment is correct and that it's accounted for at the end of the day. Because some of these companies may go public, right? And if they have public, they need that level of due diligence. So if getting it ahead of the time doesn't have you to go back through discovery of like figuring out how things are. So good capital planning up front, having it as a slow roll of the infusion is really good, because your biggest expense is going to be around the mining machines themselves. That's going to be probably your biggest expense, because mining machines are very expensive, even with their reduction in their terahash cost. But that's probably going to be your biggest expense, and you don't need all that capital up front, because mining, it might make sense to just wait like we did, where the market had rescinded and we were looking at $30 per terahash, $40 per terahash, and it went all the way down to like $12 and $15 per terahash. So we would have deployed that capital early. We would have bought machines that would have just sat in a warehouse, and they have more than halved during that time. So it's a critical piece. This is just a lesson learned when I'm telling folks out there to kind of really look at that, of when you need it at that moment in time. Plus you have to store it and you have to run security on it. So like, make sure you have a good plan there. Your machine selection. Now that's something that, like, in hindsight, we wish we would have had a little more data on, because there's just not a lot of people that cover Bitcoin miners at scale and the issues that come with it. And, I have different opinions of both WhatsMiner, the Avalon, the Canon machines, and Bitmain. They all have pluses and minuses from each other. And depending on your deployment, depending where they're at, if you have a very hot climate, it's going to matter which different miner. Like I would say our basic quick hit list, Canons do very well in the heat. They just have done very well in the heat. They don't shut down as often when they're hot. They seem to be a better hot climate miner, where Bitmain will shut off after they hit 91C. And they can overheat pretty quick, and they just have more issues when it comes to that. Like you'll get a lot of fans that just burn out faster. They really like to be temperature controlled a lot better. The WhatsMiner, they've done okay with the heat, but we seem to go through a lot more control boards than anything else on WhatsMiners and power supplies. So they handle the heat, but then they also burn through equipment faster, it seems. So that's just our own experience, and that could be just a lot of our deployments have to do with containers, and there's differences between containers and building designs. So, as an example, so some machine selection typically is what's your hash cost per terahash, and what's your replacement cost of parts. That's another piece. What parts are available? Can you get fans relatively cheaply? Can you get power supplies, without spending $300-$400 per power supply, that kind of thing. So you're going to go through these things, especially at scale. You're going to definitely go through. You're going to see a lot more. In just the 6 months that we've had, we're close to 40 power supplies out of 1,400 machines. Now that's a lot in my opinion. Like I come from like a Six Sigma world where I look at, what's my uptime on 5 nines type of thing on like a server rack in a data center. And if I had 1,400 servers, across, 40 blades, right? like with 14 servers, 1U each in each one. And I was going to, if all those bladed servers and all those different shelving units, if I went through 40 power supplies, I'd have a big issue. I'd be calling Dell or any of the OEMs going, WTF, bros. Now, granted, data centers, much more cleaner environment, temperature controlled. Probably wouldn't have the same amount of issues if I had the blade. I probably would have a lot more issues if I had those like deployed into a container. So there is some consideration there. However, it just seems like power supplies are one of those things that you go through. So when you do the math, including the cost of replacement power supplies and stuff, everything still makes sense if you're under that like 4-cent range, 5-cent range. Math still adds up to where that's just, it's a hit on your total return. However, you can still replace machines and you just have to have a cycle to that. But machine selection really from an area standpoint, and then the types, if you're going to do water cooling or immersion, all that stuff can kind of come in too. But just really understanding your climate and your area and doing the due diligence and research and feedback. Hopefully we'll be able to provide more feedback to you guys on just our experience. And hopefully that inspires other people to give their feedback on their experiences on, just what's your fail rates on this stuff. And then getting into, once you have that and you have that basic design, you get into your development, right? Like you're going to go into your architecture design. So I think you need your capital plan, you need your power options, you need your location, you need your machine selection, you need your performance set up. So then that gives you kind of your story. Like here's the design, here's the plan, right? Now, how are you going to go back and go into execution of development? So some people go in there and they do all the architecture drawings and all that stuff as part of the design. I kind of step back and say, you're going to spend a lot of money having architecture designs done. You need to really understand how your plan is going to be before you get into like finally committing to like paying an architect to go design everything. If you do that kind of up front, you might just have a whole bunch of architecture designs and not have figured out that location had some kind of permitting issue. We had that with a couple of the sites that we've helped with, to where people were just right into building, like calling an architect, spending, $10,000 on having drawings done, and just to find out that, hey, it wasn't zoned properly. Now that's a big waste of money. So this is a lesson learned. Number 2, so far that I've said, is don't go into your architecture drawings until you absolutely have full confidence that you can go and build there. You're just wasting money. So you don't want to do all that until you know the energy rate and is that going to make sense. Have it in your performas so that way you know what your return calculations could be, and then go spend the money on like your architecture drawings and stuff. This comes into like energy infrastructure as an example. So what are the requirements on like your architecture drawings? Do they need to be submitted to your city, county, province, all that kind of stuff? Like make sure, because I've seen this a few times where you have an engineering group locally that should know what the requirements are to submit them to the, maybe the board or review or a zoning committee. And then they're like, oh, you need those to submit to that. Yeah, we need to make changes to those drawings. And there's another like $3,000. So make sure you're on the same page with whoever you're working with, an architect, that they understand that, hey, we're trying to build these in a specification and design that can be submitted to a government body, that they will accept them, and that they have an engineering seal in that. So they understand that requirement up front, and you can kind of do one swing at it versus multiple swings on trying to fix your drawings to be compliant. Those are critical things that you got to know. And then infrastructure from your electrical side, you may have from your power provider providing up to a certain point, and then you're going to take over from, essentially the cabinet or the meter of like your switch gear, and then all the different power panels and things that you're going to have for your site. Now, and this applies all the way down to residential in some points, right? If you're gonna have a small mining hut in the back, and how you're gonna run maybe just an extended 200 amp service to you, you're still gonna have to have that, and how your layout's gonna be. Your layout's important because like where the heat and ventilation is gonna go. Do you have a hot and cold lane? Those kind of considerations that I'm talking about. And then how your power ramp. And I always say plan for the future, right? A lot of folks, especially if follow the channel, we were mostly all GPU. We were not designed to do a lot of heavy ASICs. It's a much higher service category. You could only get a couple ASICs in a typical house, maybe 4 at best. And then you're going to have like 4 30 amps, which are going to take up the rest of your 200 amp panel. And if you're running them continuously, when you start like turning on the oven and you have any kind of pool or anything else, and they're running them at the same time, you're going to potentially fry out your current service. So having some kind of electrical design thing is critical on having that laid out. And then your security architecture, your IT infrastructure. So implementing some level of physical security, this is part of your plan, right? Like how are people going to enter and exit? How are you going to have contractors come in, vendors, all that? Having that all kind of planned out is important. Like how are they going to access? If you can't get there to open up something, what you have multiple keys to the place, that kind of stuff. You got to look at access control systems. Like if you're inside of a building and door, like it's like I've worked with a couple sites that, you just go there and they had just a key and it's like, whoa, like you should probably put like, maybe an access card, put a maglock door, something on there that makes it a little simpler. And you're doing that because you're seeing who's entering and exiting, especially for like investment dollars that are being poured into this. Those folks are going to want to know who's in that site, right? So you got to consider that. And if you're an operator and you're building it, you want to have any level of due diligence you can have to make sure that you're able to cover down on any questions that come, like, hey, who was in there? When were they there? What time did they come? That kind of thing. Now you could do that with cameras and have normal locks. But you want to have a layout from your security architecture of the entrance and the exits and that kind of stuff, not just from theft or any of that, just really like who you're bringing in. Type of thing. And having that kind of audit log of like who's there is assuring to, having that plan, if you're putting it as part of your plan and you're raising capital for it, like they understand like, hey, you're considering like who's entering this place, type of thing. So having that out there, cameras, and how that infrastructure is going to work. Now that falls into your IT infrastructure, right? So you're going to have to consider, if you're going to be running like 4K 60 FPS cameras and multiple them on your network, you're not just using the D-Links from Best Buy. You're probably using something like Ubiquiti or some other solution that's a little more managed type of solution. You're probably going to have an NVR, where you're storing your camera footage, and then having some kind of cloud key or something to be able to upload that stuff. Again, all that's for protection. It's for you to be able to remote into if you're not there, because you're not going to be living at your farm 24/7 all the time. So you're going to want to have eyes on target type of thing. So you're going to want something that makes it simpler for you. Like I said, we like using Ubiquiti for a lot of that because it is a much simpler UI. They have a lot of updates and sometimes they've had some issues. But by and large, it's really easy to set up VLANs and all the different architectures that you're going to need, especially if you're exceeding 200 plus machines. A typical router is not going to work. You're going to need something with a little more robustness to handle both the cameras and then the physical security stuff, and then your VLAN architecture, which allows you to kind of segment your various machines across separate VLANs. So let's say you have 9 shelves, or let's say you have 30 shelves, and it's A, B, and C shelving, right? And there's 10 per, and each of those might have 10 racks. Well, you're going to have zoning that you can set up on your switches to know, well, that one's 11.1.1.5. I know that that's first rack, first shelf in whatever zone, because you're able to then manage, to a MAC address level, and a separate thing on MAC addresses in a second, because some of these miners actually have a rotating MAC address. You could narrow it down a lot faster. So what miner is down in a much larger operation, or at least what zone it's in. If you can't get it all the way down to a MAC address and you use DHCP for just those particular things, you can at least static the actual you'll put a range at the last octet, but you'll have a static range on what shelf level it is. So those things really help you on the management side of it. So where to go, to what miner to find, that kind of stuff. So managed IT infrastructure is pretty critical. The backup systems, power systems, like for us, like it was kind of an iterative thing. We had a pretty good architecture design for our IT infrastructure and our security architecture. However, when we started curtailing, sometimes we would shut down, and part of that curtailment would take down one of our primary switches, which then we lost our cameras on. And it was like, well, wait a minute here. We have to refigure this. Like everything looked good, but we weren't really considering when we would power down certain things, when we get notices power down the miners for, let's say, 4 hours from the electrical standpoint, and have, provide that load back to the grid and get a cost avoidance savings on it. But then we were shutting off our cameras, and we didn't like to have that. So we reconfigured things to where we wouldn't do that. So it's one of those things that, like, you may get through a design, you may get everything deployed, and then you got to, again, those weekly agile kind of ops tempo get you to a place to where you can understand, like, oh man, we need to make a change here. And that's okay. Document it, have a change log, that kind of thing. Having, your environmental considerations as part of that too. We start talking about planning for heat and outdoor factors, snow, ventilation, all that kind of stuff, goes into your architecture and planning, but you might have environmental sensors that get onto the network. Dampness sensors, all those kind of things you need to plan in, but you can also, add later, but, just things to consider in your IT infrastructure. It's a lot bigger than just like plugging in your network, right? That's one of the things. Let's go into deployment real quick. And don't worry, I'll take some questions and stuff from you guys in a little bit. I've seen some awesome, we've seen a super chat there. Thanks, Justin, for that. BBT is the GOAT, my dude. I'll get to some of the questions and stuff if you guys have it. I'm trying to give you guys, though, it's been a while since we've had a live stream, so I wanted to make sure it was quantitative and some quality in there too. Let's go through deployments. So deployments are interesting. This is something that I think we've iterated a lot on, especially now that essentially we're actively managing or working right now 4 separate sites. 5 if you consider a BBT site up in Wisconsin, but we've really had to get creative with the staffing side of it, right? So because there are different areas, and we're picking up contracts what seems like every week now. Like, people call us and we work through kind of a plan. They're at different stages of things, so different mines are at different levels. Some are in design, some are in that they've done some stuff, but maybe they've needed some help with some other areas. So we come in tactically and help where we're needed. We're not trying to take over the whole thing or anything. We could, but like we're trying to help where we can and kind of get them on the right foot type of thing. But the staffing is interesting if you have, if you're going to have a full-time staff, and you got to insure them, and you got to make sure for physical installations, if you're doing like a temp agency or somebody that, they come in, they have an understanding on how to work, because we're going to be working usually on a site or like on a substation. We had to have our folks have, OSHA certifications and go through training on like just electrical NEC training, because, you're around 483 phase, and you have to treat that very importantly, having the right PPE gear, if it's helmets and gloves and proper steel toe boots, that kind of stuff. So the hiring is more than just, having somebody that's going to throw some miners on a shelf by comparison. So really you got to consider some of that. A lot of folks will learn, like, this stuff is a very nascent industry. So it's hard to find somebody that maybe knows what to do and how to do certain things, but you can train them and get them up to speed on it. And then if you're going to do like repairs and stuff like that, that's a little different skill set. Probably send somebody through like Bitmain training or, what's miner training, that kind of thing, if you're going to do the O&M side of that. But, the key piece on the staffing is just hiring when you really need it. You can pre-stage it, make sure your contracts are in order and when you're going to start your date. And then that essentially, like maybe a day before or whatever, having those, temp folks come in, understand, do a 1 day with them on your site. You'll be eating that essential cost because you're not billing that to a customer. Getting them up to speed, and then you're bringing them on site. They kind of know what to expect. Just not bringing them on site and be like, hey man, here's, you don't want to have somebody very green on like a big Bitcoin site, especially if it's like a deployed site, like at a power station or something like that. You want people that have at least an acute awareness of what they're about to deal with, how heavy something is, which way to put it in, that kind of thing. I mean, we've had some of those experiences just helping, friends or whoever coming out, and then they're putting the machines on backwards, or they didn't follow kind of what we had asked, or maybe cut some of the one of our containers as an example, had a friend help and just like remove all of the zip ties. And that all the zip ties were leveled out in an appropriate way to make sure that they were going to the particular machines. But when they were all cut, just everything fell down. So it's just, having people trained up ahead of time is a lot of lessons learned there. And I look at that as like our kind of problem. Like we didn't show them what to do, right? It's not their fault. And make sure that, you kind of like make sure they're trained up enough to do that. Storage and transportation. This is one that I think some people really forget the cost in that. So if you're ordering machines, luckily we had a facility here where we could take in machines with, larger equipment. We have a skid steer that has forks, so we can lift them out of, we don't have a dock here, but we can get things with that don't have that normally would need a dock in place. But like having an ability to understand that most of the stuff's going to come on pallets, and you got to have a pallet jack and have all these things to manipulate the things around. You have to kind of account for that kind of stuff. And, if you're going to store it, having the insurance, if it's sitting in this building and we had, insurance to cover down all that, you have to, and just explaining that to an insurance company of like what it is. And it's a high dollar expense, computing item. And getting your insurance appropriately on your transportation, having, if you're going to do a lot of stuff like we're about to do here coming up, potentially an 18 megawatt site. Well, that's like 10,000 plus miners. That's a whole different level. So we got a dot number, how to register, Department of Transportation, because we're going to be using, over the road trucks and stuff. So that kind of site is a much bigger implementation, which required us to go and get different certifications to be able to move that kind of equipment. But as you're crawl, walk, running that, just knowing that you got to cover down on those kind of expenses. Moving the containers, we had to move the containers multiple times. And a lot of that came back to the pre-planning where we thought we were going to be on one substation, but then zoning came back and we had to move. So that was like two expenses that weren't really accounted for initially, right? Where we had, $3,500 to drop containers in a spot, and then I had to pay it again twice to get it picked up, moved, and then moved to a farther location. And now you have like $7,000 more in expense. So you got to have all that kind of understanding of like moving larger items and stuff on that, and organize that. Asset tagging, documentation of each machine. This goes really important. This is one of those lessons that I would tell everybody that they got to consider and understand. Having good asset management is important. Having an understanding of what serial numbers are and what the serial numbers and type of models to specific machines. If we're talking Bitcoin mining, right? Bitmain has essentially A through F on power supply types, and it's the same power supply, but there's different versions and they have different firmwares on them, and they're like symbiotically connected to the cache boards and the control boards. And there's like, if we're pulling a machine and it has an E power supply, I can't go in there and put like an A, right? So I have to make some changes. Now there's other firmwares and stuff you can kind of get over some of that, but like if you're trying to keep a consistent build, the one thing you definitely want to do is have some level of control from an asset management standpoint. So I can't have a whole bunch of like, well, this one, if I'm running this firmware, can do it. I want consistency, right? Because we're talking 1,400 to potentially 10,000 miners. You got to have a consistency to it. So asset management, when people are pulling assets and they're in different states and statuses, essentially we have like 5 statuses we put them in. We personally use Monday.com. There's no links for it or anything like that. We're not paid to say that or anything like that. It's just one that we kind of shook the tree of what makes sense from an agile development kind of operations and management, asset control, state and status of a machine. If something's ready for deployment, if it's broken, that kind of thing. So all that's controlled through that asset tag. And then we know the location, what container, what shelf it came from, all that kind of stuff. So as we're rotating machines, which happen a lot, and this is kind of in that deployment and operations standpoint, you build your operation to your power. And what that means is you want to always use all the available power you possibly can use on a larger build. So like on a 5 megawatt, we're going to get as close to 5 megawatts as we can, and we overbuy on the machines. So in that case, like 1440 machines, having 1500, 1580 allows us to always have the rotation on machines that are down, because you're always going to have, like with 1400 machines as an example, we may have 30 to 40 at any point in time that just decide to have some kind of issue. A fan goes out, a power supply goes out, something happens, and then we're grabbing the 30 replacing them with 30 good ones and bringing them back and fixing them. And so you're always doing a weekly rotation, and maybe daily if you're at the site and you have on-site support. And you're just rotating good machines for bad machines, and you're fixing them. So in your planning purposes, always overbuy on the machines. That way you're using all your available power. And that way you can keep as much uptime. And then understanding you're going to have a little oscillation at the top on your build, right? And then you're going to have spare parts that you're going to have to buy. And, in that kind of idea, like with 1,400 machines, you're going to want to, at least 100 extra power supplies and enough fans. So there's 4 fans per machine. You can get away with a couple hundred fans as your back stock. And then just kind of keeping through that depletion and having operation management, asset management system. It allows you to understand, like, what are you going through? And if you're burning through power supplies really fast, there might be some kind of issue. You might have to look at your phasing, or if you're having some kind of energy issue. You can start to identify problems pretty quick if you're recording all that information and say, hey, put it out on the internet. Like, hey, I'm kind of going through fans way fast. So is there some kind of issue going on? And you can kind of get that feedback loop from people. Talk to, your Bitmain or your WhatsMiner or your Canon support, or if you're using, KDA or any of these other type of devices, you can kind of get the feedback loop on them. And providing them information of saying, hey, here's what I've recorded. It went in at this time. It's been running for this time. It had some faulty, weird stuff happen at this time. And you're giving them not just word of mouth. You're like literally giving them telemetry from your system, right? You're saying, hey, like, all things being equal, dude, here's what's going on. Like, what's the problem? So it gives you that kind of support in the data to support those kind of operations. I kind of jumped a little there because I was talking network management and VLANs. Wire management, shelf management, get a label maker, put labels where everything's at. Machines don't necessarily need to go back to their one location, but having an idea of where they're at when you're trying to pick them is critical. Especially having some level of organization there, because maybe it's not you doing it. Maybe you're going to hire somebody and you got to give them a plan, right? You can't just say, hey, go look, good luck. Like pull the machine that's broke. It's like, hey man, shelf 5, zone 1, there's a machine that's down, somewhere there. Can you grab it? And then they can update, hey, I pulled it position 3. I put this other machine in that position. You're good to go. And now you have that kind of good management from it. Replacement, downtime, I think we kind of covered some of that. And then measurement and adaptation. There's a software piece of this that we won't really probably cover in this. I was trying to keep this for about an hour, and I want to have some time for discussion. But part of the management of all this is good software telemetry and some level of automation. So one thing we've really worked with heavily is with Awesome Miner scripting, and working with Awesome Miner to try to optimize the scripting agents on it and be able to self-heal miners and stuff. So if something goes down, maybe it overheated and it's in the middle of the day, the next reboot cycle will put it into low power mode automatically. And then at a certain period in time, it'll come back in, let's say it's 6 o'clock, 8 o'clock in the evening. It can come back in and say, it's been running pretty stable in low power, temperature's down. Let's go ahead and try to reboot it back into high power mode. So in the evening when it's cooler, it can go back into running high power. And what it'll do is it'll catch this behavior. And you can have triggers on there that when the triggers flip, if let's say it flips 3 times, that's a cycle, right? That's a continuous cycle that's happening. So then now it's going to set that as the priority. It's going to say the persistence of this miner, just for whatever reason, whenever it gets hot in the day, it overheats and we have to keep flipping it into low power. Now it's going to create that cycle automatically. So in the mornings, it'll just switch it automatically to low power. And in the evenings, it switches it back to high power. Having that kind of scripting and self-healing really fixes a lot of stuff. We've seen a lot more uptime. That's been a lot of development that we've done here at BBT to kind of help with and get, try to make our system very optimal. There's a lot, you got, a couple different options out there than just Awesome Miner that have different scripting abilities. But that's what I'm saying from like your software side, being able to record that information and understand what's really happening. This is stuff that I wish I would have really spent more time on the GPU side. It probably would have saved me a lot of trouble than just the manual operation stuff that we were doing with trying to troubleshoot miners and stuff. There's a lot of really cool scripting ability in Awesome Miner that allows that. And I know There's a couple other sites, I can't think of them off the top of my head, but that offer the same kind of services. We looked into a couple. And then you have like obviously hashboard differences and stuff, or control boards. You know, there's a few that are out there now. You got LuxMiner and a couple other ones that give you a little more fidelity and change turning off certain hashboards and stuff. I think that over time will get better and integrate with those other systems to where you can integrate both the hashboard or the control board with the miner management software to be a little more in tune with shutting off certain boards and giving you statuses of that. They're close. Right now you have to kind of go to the machine itself and kind of set it. That works really good in small farms. When you start getting over 1,000+ machines, it's a little more difficult to get in there and try to optimize for that. But it's one of those things as they're growing, and eventually, I think it will be part and parcel of that software to where, you know, not depending on the operation, you may sometimes want to say, hey, you know what, I don't want to pull that whole machine just yet. Just shut off the bad hashboard, run 2 of them. So a 100 terahash miner might drop to, you know, 60 terahash, but at least it's still running until you can get to it, right? So that kind of stuff is what I'm talking about. So you want to always have them always running as much as possible, but a good software management plan is strong. And again, I'm trying to shamelessly plug BBT and us and our services. People can go to our website, they can request service, and we can help them at various stages. But like, I'm trying to make this information kind of open source to you guys. Again, this is the recipe and ingredients to the lessons learned that we've had. And I think it's critical in sharing it with you guys. Because, I mean, we see other folks share the same kind of information in some way, in some tweak. And I think it's lead by example type of thing. So that was my kind of spiel, my dudes. 50 minutes. Again, it's in the video descriptions. A lot of the stuff I just covered, if you missed it. Foreman, that was the other one I saw in the, we've tried to use Foreman. It's the scripting ability isn't as good that we've seen as Awesome Miner. It does have some really cool stuff with like curtailments and stuff, but like, there's still some, if we could merge them, it would be fantastic. Yeah, missed you guys. Let me see some comments here and then we can wrap this one up. GM from Bolivia. I hear you, my dude. Soaking it all in. Good information. That's cool. Using any smart PDUs. Where did you get them from? We are not on at least one of the sites. A couple of the other sites have the Bitmain N5s, and they do have PDUs, but they're not smart ones. What are the disadvantages and questions that should be asked to locate in a shared location? In a shared location, I would make sure that in any kind of shared location they have a good, you know, like heat dissipation or some kind of like a hot cold lane to make sure that they understand that when as they add more people that it just doesn't start to affect the whole group. That they have the, you know, what are their processes to keep you up? Do they have any metrics to show you uptime, that kind of stuff? From Argentina, building an immersion cooling. Nice, my dude. Yeah, we were going down the immersion route up in Wisconsin, and then we really started scaling with the outdoor containers. And it's just not in Wisconsin. So like moving all that stuff and all the plumbing and stuff that we did up there and stuff, it's just, we kind of paused that whole process. Because that was really designed for GPUs. The whole immersion cooling solution that we had up there, the tanks, all that was real. The flow plates, everything was designed for GPU rigs. So now that we've almost all ASICs right now, not a lot of GPU stuff really running. I have stuff running on Flux, ETC. I have a couple ETC ASICs, and then I have 2 full A5000 rigs running Ravencoin. Can you get 4 cents without curtailing? Yes, if you're behind the meter, you can absolutely get that. around 3.8, and then you'd have some kind of probably co-hosts or profit sharing solution that would keep you right around 4 cents. Yeah, I wish I could have more stuff, guys. We have so the original so we had a person that's a follower help us with a video, the previous video, and we're going to look at how we can integrate their efforts in getting more content out on top of my original, I would say, creative and videographer person that was doing our first one, like from the original BBT videos from 2013, has now his own company doing media stuff, and we're looking to doing some integration on some new videos with him. So we should have some kind of tutorial type of videos and just observe report stuff right now. But a lot of it is, what we can do to help the community. And if, you have, if you're a watcher and you have, capital you're trying to deploy, setting up a session with us is fine. You guys can always go to a website and do that, and, do kind of a feasibility report, right? I mean, there's things that we can do with that too to help folks. All right, my dudes. Let's see here. Would you do a 483 phase to one phase 240 worth it for a 20-foot container? Well, I would say you would have to do that if you're going to try to fill a 20-foot container. You're going to have some level of 3-phase service. Most stuff is 480, 277. The good thing is most of the miners out there now support 480, 277 directly. Most power companies that bring you that level of service, are giving it to you in 480, 277. So you could, you would do that to your service. You do the 3-phase 480 to your panel, and then your panel would come out with one of the legs to neutral and bring you, your single phase at 277, unless they have it like 415, 240. Do you see batteries catching up and becoming a use case for smaller scale operations in more expensive regions? I mean, the amount of battery power you would have to have, or the amount of battery density you would have to support like a mining operation is pretty substantial. I mean, unless there's some kind of super breakthrough in battery power or battery storage, I wouldn't think so. I see a lot of people that try to use kind of mixed services with like where they're grid tied with like solar. So their demand on the grid is very low because they have most of their solar coming in during the day. And then they're at grid at night. So what the solar is offsetting is their daily peak rates. So some people are like, oh, don't do solar, because you can't store enough to do it at night. Well, your night rates are probably pretty cheap in most places because people are not using power. Now, the interesting dynamic is a lot of that could be changing as we get more and more people on electric cars, because now the nighttime isn't necessarily low peak because everybody's going to be charging their freaking cars at night when they're sleeping. So it's going to be interesting over the next like 5 to 8 years when we start to see how big of an impact is going to be electric cars charging on the grid at night. And is our peaks going to pivot to where the peaks are at the night because everybody's charging their damn electric cars? So it's going to be pretty interesting because electric cars use a crap ton of energy. So it's going to be interesting over the next few years, and like from a hedging standpoint and power costs and stuff. So I'm just hoping, some breakthroughs are on the power side, from a generation standpoint. We'll see. Random question, BBT. If you had to buy one coin right now, which would it be? It'd always be Bitcoin. It's the anchor. It's got the most hash rate of any coin. It's decentralized. It's standing up to all the regulatory fuss. And it's just, stacking sats, man. Always. even back in the day when we were mining Ethereum and stuff. I think Ethereum has a couple existential issues that it's still dealing with right now with Lido taking, I mean, it's almost 38% of the network. When you look at the way the acetations and everything work, and with just the way the DAO's set up with it, it's going to be interesting what Ethereum's going to do with that. I mean, we all knew it was going to happen. I mean, it was just I've been talking about this for 2.5 years that Ethereum would end up getting super centralized and have a risk of existential centralization with being most of its nodes hosted on the world's clouds. They could pivot though. I mean, it's not that hard to pivot. So I take it with a grain of salt, partially because like if there was an existential threat from the world's clouds, I would think that the majority of Ethereum's network would get really smart really quick on how to host off of their own local nodes. And then they would pivot. It's the least line of resistance type of thing. Like humans naturally will go to things that aren't painful. And if you have this like one-click solution these days to deploy your Ethereum node on a cloud, like you're going to do that, or you're going to go through setting up and all the risk and stuff, setting up your own node locally. You're going to be like, man, I ain't got time for this. I'm going to do the one-click option, right? So I think that's what the situation is, just being open, and I think that's what it is. But like, you know, that's the reason why I wouldn't have chose Ethereum on that. But like, if we'll see what happens. Where do you mine at your sites? Almost all of it's Bitcoin. Yeah, I should have said other than Bitcoin. Other than Bitcoin, I mean, I'm a very strong believer. I've been in it for a long time in Raven. I like where Flux is going because it's different. There's things that concern me a little bit with Flux, just from the conversions and stuff that have to be done from Flux itself, like when you're moving between networks and stuff, some of the parallel mining stuff. And it's really around just the centralization of that has to be done through like the Flux network operator, which, you know, but I think it's kind of on the trilemma victim of circumstance type of thing. You're trying to provide a set of solutions and services, and to decentralize all of that's super hard. And it's way easier to kind of kick that off initially with having an entity that does it. So I'm not necessarily counting it against them, but Flux, I think, has that kind of issue. I mean, that's really what I've been focused on. When I look at the regulatory risk and issue that we're seeing in the SEC and everybody, like Ravencoin is a fair market launch. It's a lot like Bitcoin. It just happens to be mined with GPUs. So that's why I've always chosen Raven. Again, Flux has its stuff. Having those available on larger exchanges, not necessarily Binance. Binance is pretty large. It's still worried about the contagion with Binance. I don't think BNB and all that's had its day yet on the regulatory risk of it. And we'll see if that ends up impacting, you know, Binance in the long run. There's a lot of fraud in the system when it comes to all that stuff. So I'm just waiting for that to all kind of come down and what's going to happen with all that. And is there going to be more contagion that comes out of all the FTX stuff? But what I do know is the coins that are not caught up in all that, did not have pre-launch stuff, did not have backroom deals with like investors to get tranches of coins. Like anything that's touched any of that just doesn't feel right because of the transparency pieces of it. And so like things that are fair market launch, I think, are just a better bet in the long run. It's ultimately the best way to do it, in my opinion, but that's just me. All right, my dudes. Well, I'm going to wrap this one up. Hopefully it was good. It's been a while since I've had a live stream. It's been a long while since I've had a live stream. I miss it. I haven't forgot how to do it, my dudes. Hopefully this came off pretty like normal live stream. It's just about finding the times to do it. And We'll try to get a more regular schedule with that. I'm genuinely trying to get this factored back in to have these conversations with you guys. I have a lot to talk about. There's so much to talk about that we could peel back any of the things I just talked about and really deep dive in any of those. So hopefully it was good for you guys, and I will catch you guys on the next one, my dudes. Peace.